Hello, dear students. During this lesson we will discuss questions 12 and 13 from the second section of the official 2007-2008 SAT Practice Reasoning Test. Question number 12. Marbles are to be removed from a jar that contains 12 red marbles and 12 black marbles. What is the least number of marbles that could be removed so that the ratio of red marbles to black marbles left in the jar will be 4:3? If we remove 3 black marbles from the jar, then the ratio of number of red marbles to the number of black marbles left in the jar would be 12:9, which is 4:3. So number 3 works. If we remove 3 black marbles, then the ratio would be 4:3. But why 3 is the least number of marbles that could be removed? Maybe we can remove 1 or 2 marbles and the ratio of the number of red marbles to the number of black marbles left in the jar still would be 4:3. Notice that initially we had 12 red marbles and 12 black marbles in the jar, and number 12 is divisible by 4 and 3. And if the ratio of two natural numbers is 4:3, the first number should be divisible by 4 and the second should be divisible by 3. Therefore, the number of red marbles left in the jar must be divisible by 4, and the number of black marbles left in the jar must be divisible by 3. If we remove 1 or 2 marbles from the jar, then either number of red marbles won't be divisible by 4 or number of black marbles won't be divisible by 3. Therefore, 3 is the least number of marbles that could be removed. Question number 13. For the system of equations above, if x doesn't equal to 0, what is the value of p? We are given system of 3 linear equations. Number of variables involved in the system equals 4. Variables x, nu, t, and p. From this system of 3 linear equations we have to find the value of p. Let us see how we can do it. From the third equation we can express p in terms of x and t. P equals x over t. From the first equation we can substitute the value of x. X equals 3 nu. And from the second equation, instead of nu, we can substitute 4t. So in the numerator of the fraction we will get 12t, and we can reduce this fraction by t, and the answer would be 12. So p equals 12. Why in the text of the problem we see that x doesn't equal to 0? Why do we have this restriction? X is not 0. Because all our manipulations which we performed here are correct only in case when denominator is not 0. Denominator doesn't equal to 0. So t cannot be equal to 0. But why t is not 0? Because if t is 0, then from the second equation we will get that nu equals 0, and then from the first equation we will get that x equals 0. But it is given that x doesn't equal to 0. Therefore t is not 0, and all these expressions are defined. Therefore, everything is correct. The answer is 12. Our lesson is over. Thank you for participation. This was Vladimir Luzgin. Goodbye.